today we're going to talk about a hyperbola, which is the set of all points such that the difference in the distances from the point to the two focal points is constant. So very similar to the definition of an ellipse, the only difference is we're taking the difference in the distances. We are not adding the distances this time. So what we need to do is get our setup. So we know that the point to focus 1 minus the point to focus 2 is constant. We're going to set that constant equal to 2a. We saw earlier that a is the distance from the center to a vertex, and this would be the length along the transverse axis. The only other thing that we need to consider is we actually really want to take the absolute value here, because point might be closer to focus 1 than focus 2. We want the difference in the distances to come out positive. Another way of writing that would just be point focus 1 minus point focus 2 is equal to plus or minus 2a. So you have a choice with which one you want to use. I'm actually going to prefer this one for our derivation. So just like last time, I want to get a little bit of a setup here. So we have our hyperbola, which is going to open up horizontally. We call these points the vertices, which we will say are at A0, and we've got negative A0 based on our setup. And then we have our focal points, which I'm going to continue to use C as our focus to center distance. So C0 and negative C0. So any point on this hyperbola, so we'll call this point P, point to focus 1 minus the distance from point to focus 2 should be constant. So again, I'm going to use the distance formula. So if this point is some point x comma y, we know that the distance from point to focus 1 would be x minus a negative c, so x plus c squared plus y squared, minus the distance from point to focus 2, so that would be x minus c squared plus y squared, or y minus 0 squared, is going to equal our plus or minus 2a. So this is the formula we're going to spend some time simplifying. So this is the equation we're starting to simplify. And what I'm going to do first is I'm going to move this negative square root term to the other side. I'm not going to simplify what's inside. I'm just going to leave it unsimplified. So x plus c squared plus y squared is going to equal the root x minus c squared plus y squared plus or minus 2a. At this point, I'm going to square both sides, which is going to work out pretty nicely on my left side, getting rid of my square root. So this is going to be x plus c squared plus y squared equals, and on the right-hand side, my first term will just be the first term without a square root anymore. My middle terms are going to be plus or minus 4a times the square root, which I'll write down here just to see it gets some more room involved. X minus c squared plus y squared. And my last term is going to be the square of the second term. So that's going to be a plus 4a squared, right? The minus squared and the plus squared both come out positive. So again, my goal is to isolate the square root such that when I square it, it would go away. So I'm going to move all the non-square root terms right now to the left-hand side. And I'm going to expand. So this is going to be x squared plus 2xc plus c squared plus y squared. And I'm going to subtract the x squared minus 2xc plus c squared minus a y squared and minus a 4a squared. So I've moved this and this to the left-hand side, and that's going to be equal to my plus or minus 4a square root term. So hopefully you notice that things are going to start to cancel. So we definitely are going to be able to cancel out an x squared. We're going to be able to cancel out a c squared. And we're going to be able to cancel out a y squared. And what I'm left with is 4xc minus 4a squared equals plus or minus 4a, and my square root term still. We're so close. We got this. So again, I notice everything is divisible by 4, so I'm going to divide by 4, and that's xc minus a squared equals plus or minus a square root term, x minus c squared plus y squared. And finally, I've gotten to a place where I can square both sides. So on the left-hand side, I'm going to get an x squared c squared minus a 2xc a squared plus a to the 4th. On the right-hand side, I'm going to get an a squared, right, because the plus or minus is again going to just become a positive, which is great. We don't really want a plus or minus in our final answer. And I'm going to have my x minus c squared plus y squared. So now what I'm going to do is work on expanding my right side. So I'm not going to rewrite the left. And I'm going to distribute the a squared. So we're going to get an a squared x squared. We're going to get a minus 2a squared xc. We're going to get a plus a squared c squared. And we're going to get plus a squared y squared. And luckily, we do get something that cancels out at least. What we want to do is move all the terms with x and y to one side. So we're going to leave those here. And we're going to bring this x squared over. But we want to move things that don't have x or y to the other side. And what that leaves us with is a to the 4th minus a squared c squared is equal to a squared x squared minus c squared x squared plus a squared y squared. So again, we need to go back to our picture to help us realize what simplifications we can make. So just drawing half of a hyperbola, we have our vertex and we have our focus. So this distance we're defining to be C, and this distance we are defining to be A. And by a Pythagorean identity, we can see that a squared plus something, which we will call b squared, is equal to c squared. So in this case, a squared minus c squared is equal to negative b squared. So when we factor our expression that we have, we can factor out our a squared. We get an a squared minus c squared equals x squared times a squared minus c squared plus a squared y squared. We can make the substitution that a squared minus c squared is negative b squared this time around. So a squared times negative b squared is equal to x squared negative b squared plus a squared y squared. And now we're going to divide both sides by negative a squared b squared. And what that's going to leave us with is 1 equals x squared over a squared minus y squared over b squared, which is the formula for a hyperbola centered at 0, 0. Again, if we want to use transformations and make the center hk, we just need to change our equation around to be x minus h squared over a squared minus y squared over b squared. So this is for a hyperbola that opens up, we say horizontally. In order for it to open up vertically, we really just have to envision reflecting over y equals x. And when you reflect over y equals x, you can think about switching the x and y. And that would make the equation instead y minus k squared over a squared minus x minus h squared over b squared. So that's the difference if you want a hyperbola that opens up vertically versus one that opens up horizontally.